Hi, welcome to lesson 22G, sampling with and without replacement. The goal of today's lesson is to learn how to calculate the probability of sampling with and without replacement. So if we have a large group of items of some sort and we randomly select them and inspect them for some sort of particular features, this process is known as sampling. Sampling is important in terms of quality assurance if we want to find out, for example, the exact volume of liquid in a Coca-Cola bottle, or the exact number of matches in a matchbox, or the length of time that a light bulb will last. We need to sample these things to then determine what kind of quantity it has or durability in terms of the light bulbs. If we sample something, some sort of item, and then put it back before the second item is removed, that is called sampling with replacement. And if we have the replacement, then that means that the second time we sample the item, there's the same number of items that we began with. So regardless of what we got in the first draw or first sample, we'll have the same amount of objects remaining. Therefore, the probabilities will be the same in either case, and therefore these things are called independent probability, or independent events. If we then decide, okay, well let's do a sample without replacement, then what happens is, by virtue of removing one item, we have decreased the total number of items that we're going to draw from. The sample space is changed, therefore the probability gets changed for the second draw or the second sampling. Therefore these are called dependent events, because the probability of the second sampling is dependent on the probability of the first, or the fact that one of the items is removed from the sample space. Okay, let's take a quick look at an example that we looked at the other day. We looked at the idea of a bag of marbles. Remember that beautiful drawing I made on the last video? So we've got 3 black marbles in the bag and 5 white marbles in the bag. And so on the first draw, the probability of randomly selecting a black marble is 3/8. The probability of randomly selecting a white marble on the first draw is 5/8. Now if this is with replacement, then that means that the probability of drawing a black marble on the second sampling is still going to be 3/8. And even if we choose a black marble, the first draw, the probability will be 3/8 for the second draw, and for white it'll be 5/8, just like the original probability. And the same goes if we choose a white marble first, randomly select a white marble that is, then the probability of selecting or drawing a white marble the second time is still going to be 5/8, because we replaced that white marble after we drew it. And the same thing for the black marble. The probability of the black marbles is still going to be the same, 3/8, because we have replaced that marble that we chose, or selected, I guess, and therefore we still have 8 marbles in the bag when we do the second draw. So the total probabilities, this is independent events, because the probabilities don't depend on what we drew in the first place. So if we draw a black marble and then the second draw is a black marble, the probabilities is 9/64. If we draw a black marble and then followed by a white marble, we can see that the probability is going to be 15/64. And same thing if the white marble is first, then the black marble is the probability of this scenario is going to be 15/64. And then the probability of drawing a white marble followed by a white marble is going to be 25/64. And if we were to add all those probabilities, because these are the only outcomes that are possible, if we add together all these probabilities, it's going to add up to 1. Which means that with definite certainty, when we draw 2 marbles out of the bag, one of these 4 outcomes will occur, definitely. And if we repeat the process, and we end up getting all of these at some point in time, the probability of that happening will equal 1. Okay, so now let's take a look at the event where we have that we are not replacing. So this is without replacement of the marbles. And so at the beginning, the very first draw, we still have 8 marbles in the bag. 3 of them are black and 5 of them are white. When we draw, we randomly select a black marble out of the bag. That probability was 3 out of 8. On the second draw, we now have, since we've removed one of the marbles from the bag, we now only have 7 marbles in the bag that are remaining, and only 2 of them are black. We started with 3, we drew a black marble out, now there's only 2 left. There's still 5 white marbles in the bag. However, the probability of drawing a white marble has now increased because the total number of marbles in the bag has decreased by 1, the marble that we pulled out before. And then the same thing goes here. If we randomly select a white marble, the probability of that would have been 5 out of 8. But then after that, because we did not replace the marble, then the probability of drawing a black marble on the second draw would be 3 out of 7, because now there's only 7 marbles in the bag, or the probability of drawing a white marble is 4 out of 7, again for the same reason. We took one of the 5 marbles away, so that leaves us 4, and we took one of the 8 total marbles away, which is that white one, leaves us with 7 altogether. So then if we follow along the branches, then a black marble followed by a black marble being drawn out of the bag gives us a probability of 3/8 multiplied by 2/7, and that gives us 6/56. Then a black marble followed by a white marble is 3/8 multiplied by 5/7, which is 15/56. Same probability if it's white and then black, and then 2 white marbles following each other on the draws, 5/8 multiplied by 4/7, which is 20/56. And then of course, because these are the only outcomes that are possible, it is with certainty that at least one of those outcomes will occur. And therefore, if we were to add all the different probabilities together, we will get a value of 1. So I just wanted to clarify something. In the last video, I discussed the fact that the probability of 2 independent events occurring you would calculate that by finding the multiplication of those 2 probabilities. But in the examples we just looked at with the black and white marbles, whether the events were independent or dependent, the probabilities were still multiplied together. And just to clarify this, suppose we had event A, which had the probability of, say, 1/2. So event A, the probability is 1/2. So let's take a look at these. There's 60 dots here. So probability is 1/2. Then if we were to take this, these are the 60 likely, or 60 equally likely outcomes to occur. So the probability of event A occurring is half of those. Okay, so it's 50% likely that event A will happen. So suppose the probability of event B is 1/3. Then we would take 1/3 of these total outcomes, and we take a look at those, or these would be the 33% roughly probability of event B occurring. Notice then that if event A occurs and event B occurs together, that's in this intersection of those two ovals I just made. And so the probability of that would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the probability of A and B occurring, the intersection, is 10/60, which is 1/6, which is the same as the probability of A multiplied by the probability of B, which is 1/2 times 1/3, which is 1/6. Okay, so whether it's independent or dependent, the events, the probability that they occur at the same time is calculated by multiplying the probabilities together. Okay, another way of looking at it is, suppose we look at it as if we think of, suppose, event A occurring half of the time and event B occurring 1/3 of the time. Well, if we want to find out when of the times that event A will occur, we want to find out how many times B would occur. So if for each of the half times that event A occurs, there's 1/3 of the time that event B occurs, well, 1/2 of 1/3 is the same as 1/2 times 1/3, which is 1/6. Okay, so in terms of us determining final probabilities when we're sampling 2 or 3 or 4 times, we take the individual probabilities and we multiply them together to get the final probability. Okay, so I hope that clears things up a little bit. If you still have a few questions about that, please don't hesitate to ask in class tomorrow. So we're going to look at a few examples tomorrow in class, but in the meantime, what I'd like you to do is I would like you to take a look at examples 13 and 14 on page 589 and follow along with the self-tutor, and also then take a look at the practice exercises 1 to 10 from pages 589 to 590. So, thanks for watching, and we'll see you in class.